Welcome to this explainer. Today, we're uncovering the fascinating science behind why our absolute favorite red berries decay so fast, and crucially, how we can actually stop it. Whether you're growing them out in your backyard or just trying to keep them fresh in your kitchen fridge, you're definitely in the right place.
So, ever wondered why your strawberries spoil so quickly? Let's dive right into this incredibly relatable frustration. You buy this beautiful, perfect little basket of strawberries, pop them in the fridge, and literally days later, boom, they're covered in fuzz. It kind of feels like a losing battle, right? Well, today, we're going to arm you with the scientific insights and practical tips you need to actually win it. Take a look at these visceral, up-close details. We're not just talking about a slight blemish here. It's a complete structural breakdown of the fruit caused by some relentless microscopic enemies. These fungi just lay in wait in the shadows, ready to absolutely wreck these precious red jewels. And honestly, it's a multi-billion-dollar problem for the global food industry, not to mention a massive headache for us at home. We've got a really clear roadmap for today. We're going to cover the problem with strawberries, meet our fungal villains, see how the environment actually fuels this rot, look at field and garden prevention, figure out how to perfect post-harvest storage, and then wrap up with a quick summary and professional disclaimer. Let's get into it.
Starting off with Section 1, the problem with strawberries. They are highly perishable and under constant threat.
The really crucial point to understand here is that even under the best, absolutely ideal storage conditions, strawberries are incredibly perishable. This makes them uniquely vulnerable to post-harvest decay. I mean, think about it. Unlike apples or oranges that have these thick, protective outer layers, strawberries have incredibly delicate skin. They're super sensitive to handling, high humidity, and temperature changes. Naturally, their absolute maximum shelf life is only about 5 to 7 days, so they are quite literally in a race against time from the exact second they're plucked from the plant.
Moving on to Section 2, meet the fungal villains. These are the microscopic antagonists ruining your harvest.
Okay, so there are specific fungal species we're battling here, and each one leaves its own destructive signature on the fruit. First up is Botrytis cinerea, commonly known as gray mold. That's the one that leaves that classic fuzzy gray decay we all completely dread. Then we have anthracnose, which creates these small, hard, sunken dark spots. Now, if you've ever found a berry with a firm, dark brown spot that smells totally pungent and tastes intensely bitter, yep, you've met leather rot, caused by Phytophthora cactorum. And finally, rhizopus, or black rot, which rapidly turns the berry into a limp, leaky, water-soaked mess covered in this white, fluffy cotton. Gross, right? Just to give you an idea of the sheer scale of this threat, gray mold alone can cause a staggering 80% yield loss right out in the field. 80%! And a big reason for this is that this specific pathogen has become highly resistant to many standard fungicides over the years. It is a massive exterminator hazard to crops all around the world.
Now notice the hard sunken lesions visible right on the surface of these fruits. That's anthracnose. But here's the thing. Anthracnose is incredibly deceptive. It doesn't just attack the berry you actually want to eat. It's a super aggressive pathogen that can also infect the plant's runners, stems, and even the crown itself, which can lead to severe stunting or even total plant death. It is literally a full system invader.
Which brings us to Section 3, how the environment fuels rot. We're talking warmth, moisture, and the rapid spread of spores.
Look at how rain splash physically launches spores right onto healthy tissue. Fungal spores are incredibly light, So a single drop of rain hitting an infected plant acts like a microscopic explosion, shooting these spores across short distances directly onto uninfected flowers and fruit. Add in extended moisture and warm temperatures, and you have the absolute ultimate fuel for an outbreak. Without water, these spores simply can't germinate.
But honestly, beyond just the rain, these pathogens are total expert survivalists. Overhead irrigation, huge risk factor, because it creates prolonged leaf wetness, which perfectly mimics a rainstorm. Plus, pathogens like the one that causes anthracnose can literally survive in the soil for up to 12 months under dry conditions, just waiting for the perfect moment to strike. They can even hide out inside nearby weeds, completely symptom-free. And get this, over-fertilizing with excess nitrogen actually makes the plant tissue more susceptible to fruit rot when the weather conditions align. Crazy, right?
Let's jump to Section 4, Field and Garden Prevention. Here are the agronomic defense strategies you need for healthy plants.
Okay, here is your actionable checklist, whether you're managing a farm or just your backyard garden.
First, you absolutely must start with certified disease-free nursery plants. Why? Because a lot of infections actually arrive completely symptomless on new transplants. Next, strict sanitation is vital. You got to actively remove dead or infected plant material to get rid of the pathogen buildup hanging around. Applying mulch is an absolute game changer too. It creates a physical barrier so your berries aren't resting straight on the dirt, which is exactly how leather rot overwinters and infects the fruit. And lastly, never harvest when the plants are wet. You'll just end up spreading spores everywhere with your hands and tools.
Maintaining a healthy, well-spaced plant structure is really your first line of physical defense against excess moisture buildup. By giving your plants enough breathing room, you maximize the airflow straight through the canopy. And this is huge because it speeds up the drying process after a rain or morning dew, effectively robbing those fungal spores of the extended moisture they desperately need to germinate.
Now, using what agricultural experts call protected culture, things like low, high, or caterpillar tunnels, physically blocks the rainfall from hitting the plants altogether. Remember earlier how we said water is the main trigger? Well, by just keeping the rain off your strawberry flowers entirely, studies show that botrytis fruit rot, that awful gray mold, becomes almost completely non-existent. That's a real game changer. All right, Section 5, Perfecting Post-Harvest Storage. This is the race against time and temperature.
Now that they're picked, time is totally of the essence. First off, because of that super delicate skin we talked about, strawberries have to be harvested with incredible care to avoid bruising. Any bruise creates an open wound for secondary infections. But step 2 is the absolute most critical part. You have to rapidly remove the field heat from the berries. If you don't strip that heat and bring the fruit down to 4 degrees Celsius or lower within just 2 to 3 hours of picking, the natural respiration of the berry actually generates even more heat, which just sends fungal decay into overdrive.
When we compare standard room cooling to forced air pre-cooling, the data heavily favors forced air. Standard methods often just leave internal heat trapped deep inside the berry cluster. But forced air pre-cooling? It actively pulls cold air directly through the packaging, rapidly lowering the absolute core temperature of the fruit. This effectively hits the pause button on microbial growth, preserves all that good nutritional content, and delays spoilage right at the source.
And the results of doing this are just phenomenal. By utilizing optimal forced air pre-cooling methods right after harvest, commercial suppliers can push the shelf life of a strawberry to a remarkable 15 days. That's a full 3 days longer than standard cooling techniques like room cooling or vacuum cooling. It just proves how absolutely critical temperature control really is.
So, what's the big takeaway for your home fridge? You want to get those berries as close to 0 to 1 degree Celsius as possible, without actually freezing them. Your standard fridge might be set just a little bit warmer than this, which is exactly why your berries are spoiling faster than you'd like. Oh, and here's a pro tip. Never, ever wash your strawberries until the exact moment you're ready to eat them. Running them under tap water before storage just restarts that whole fungal infection cycle we work so hard to stop out in the field.
Finally, Section 6, Summary and Professional Disclaimer. Let's wrap up our farm-to-fridge journey.
We've covered a ton of scientific and practical knowledge in this explainer today, but please keep this professional disclaimer in mind. While these agronomic and storage practices are rigorously backed by science, you should absolutely always consult a local agricultural professional or extension office if you're dealing with severe crop infestations. They're the ones who can provide personalized advice and specific, legally compliant chemical control programs if you're facing a severe commercial outbreak. So, we've covered the microscopic villains, the environmental fuel they desperately need, the farm prevention techniques, and the absolute necessity of rapid cooling. But I want to leave you with one final question. Knowing what you know now about how moisture and temperature totally dictate the lifespan of your fruit, what will you change about how you store your strawberries today? Keep them dry, keep them incredibly cold, and enjoy the fruits of your labor. Thanks for joining me on this explainer, and keep learning.